The equilibrium constant Kp and temperature T in Kelvin are linked by the mathematical relationship shown in equation 5.1. R is the gas constant in joules per mole per Kelvin, and delta H is the enthalpy change in joules per mole. Part A. The table shows the values of Kp at different temperatures for an equilibrium. Complete the table by adding the missing values of 1 over T and ln Kp. So firstly, the key thing we need to notice about this table is that everything is to 3 significant figures. So that means our answers that we put into the lines must also be to 3 significant figures. So in terms of calculating 1 over T and ln Kp, you need to plug in the value for T and then do 1 divided by this value. So for 500, that's going to be 1 over 500, which is 2.00 times 10 to the negative 3, and that's to 3 significant figures. And then if we do the same for 600, 700 and 800, so 1 over 600 is 1.6 recurring, so 6, 7 times 10 to the negative 3. Then 1 over 700 is 1.43 times 10 to the negative 3. And then 1 over 800 is 1.25 times 10 to the negative 3. So that's our first line of the table done. Then to work out ln Kp, you type in ln and then your Kp value. So that's going to be 5.86 times 10 to the 45. So the natural logarithm of this is 105. Then if we continue, so the natural logarithm of 1.83 times 10 to the 37 is 86. The natural logarithm of 1.46 times 10 to the 31 is 72. And finally, the natural logarithm of 1.14 times 10 to the 26 is 60. So for this row of the table, the ln Kp row, you have to have whole numbers. But for the 1 over T row of the table, you need to have it to 3 significant figures. So to get the 2 marks for this question, you get a mark for each row of the table. Your 1 over T row has to be to 3 significant figures, and then your ln Kp row has to be a whole number. And that's how you get the 2 marks for this question. Part B. State and explain how increasing the temperature affects the position of this equilibrium and whether the forward reaction is exo or endothermic. So the first thing we need to do with this question is look at the table that we've been given. So as temperature increases, Kp is decreasing. So the general expression for Kp is the partial pressure of your products divided by the partial pressure of your reactants. So if Kp is getting bigger, that means your numerator is bigger, and that means that the equilibrium position has shifted to favour the products. But if Kp is decreasing, that means that it's favouring the reactants and the denominator is bigger. So that means that the equilibrium position has shifted to the reactants, which is the left. So that's the first statement we're going to write here. So we need to write our first statement, which is equilibrium position shifts to the left. So the left is the direction of the reactants, and that's why our denominator is going to be bigger, and that's why Kp is going to decrease. So now we need to think about whether the forwards reaction is exo or endothermic. So temperature is increasing in this table and this question. It says it's increasing the temperature. When you increase temperature, the equilibrium position will move towards the endothermic direction. And here we've said that the equilibrium position is shifting to the left. So that's towards the reactants, and that's the backwards reaction. So if the backwards reaction is endothermic, that means that the forwards reaction must be exothermic. So this is the second statement that we're going to write. The forwards reaction is exothermic. And these two statements, you need to have both written to get the mark. Part C. Plot a graph of ln kp against 1 over t using the axes provided on the opposite page. Use your graph and equation 5.1 to determine delta H in kilojoules per mole for this equilibrium. Give your answer to 3 significant figures. So for this question, I have copied across the information from the table we completed in part A and equation 5.1, which is written in purple. I've also now plotted the ln kp and 1 over t values on the graph provided. The next step in answering this question is drawing a line of best fit. The reason we're going to calculate a gradient is because the equation 5.1 resembles y equals mx plus c, where m is the gradient, c is the y-intercept, and then x and y are x and y, or in this case ln kp is y and 1 over t is x. So working out the gradient is going to equal minus delta h divided by r. So in order to calculate the gradient, we need to draw its line of best fit. And the line of best fit is only going to go through the points that we've plotted. So now we need to work out the gradient. And we can use these 2 points in green to work out the gradient from. So we have 94 and 64. And then we have 1.35 times 10 to the negative 3 and 1.85 times 10 to the negative 3. So the gradient is delta y divided by delta x. So the change in y is 94 minus 64, and then the change in x is going to be 1.85 times 10 to the negative 3 minus 1.35 times 10 to the negative 3. So this is going to equal 60,000. And then we want to work out delta H. So we need to multiply by R. So that's going to be 60,000 times by 8.314, which equals 498,840 joules per mole, but we want our answer to 3 significant figures and in kilojoules per mole. So that's going to be 499 kilojoules per mole. Then another key thing in this question is that we have a negative sign in our gradient. So that means that we need to have a negative in front of our 499 kilojoules per mole. This also means that the forwards reaction is exothermic, which we wrote in the previous part of the question. So having this negative sign is definitely what you need to do. If you're ever in any doubt about whether you want a negative or a positive, look at if the forwards reaction is exo or endothermic, and if it's exothermic it will be a negative delta H value, and if it's endothermic it will be a positive delta H value. To get the 4 marks for this question, you get a mark for plotting your graph, so all the points need to be correctly plotted and there needs to be a correct line of best fit. Then you get your second mark for your gradient, which can be in the range of 57,000 to 63,000. You get a mark for multiplying by 8.314 or R. And then you get your final mark for then writing to 3 significant figures and dividing by 1,000, so it's in kilojoules per mole, and then having your negative sign. All of this gets you your 4th and final mark for this question. Part D. Explain how delta S could be calculated from a graph of ln kp against 1 over t. So we already worked out what each thing means in equation 5.1. So negative delta H over R is m, which is the gradient, and c is delta S over R, and c is the y-intercept. So the first thing we need to do is measure the y-intercept. You could also say that you're going to extrapolate to find the y-intercept. And the y-intercept is going to equal delta S divided by R. So delta S is going to be equal to R multiplied by the y-intercept. To get the 2 marks for this question, you get a mark for saying that you're going to measure the y-intercept, and then you get a mark for saying that you need to multiply this by R.